Let's see. Crap. My speaker is all weird. When is this due? It says when it's due. So when you guys try to access the quiz, it says it's locked, right? But you can, like somebody just told me, they could see when it's due. Yeah, it's due by 4 o'clock. There you go. Nicole's being nice. Yeah. People are still coming in. So as you guys come in, let me know if you have questions. I kind of want to go over questions to let more people get here before I talk about what the quiz is going to be like. Also, as you come in, let me see. Is anybody... All right, I like it. Everybody's got their first and last name. Kick ass.
Can I ask a little bit further about 42? I just want to make sure I get it right. So I can cross multiply the 1/4 and the equals to
negative 1/4, right? Negative 1/4.
Negative 1/4 equals 1 minus c over c squared minus c.
Yes.
Okay, so I cross multiplied that and it became negative c squared plus c over 4 minus 4c.
No. You didn't cross multiply correctly.
Okay. What did I do?
When you cross multiply, all fractions should be gone. So when you cross multiply, you bring one bottom up to this side of the equation and the other bottom to the other side of the equation. You can't suddenly make your equation
that one.
Yeah.
So it'd be 4 minus 4c equals negative c squared plus c.
There you go. And now it gets equal to 0, you factor, blah, 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 blah. Or you do quadratic.
Okay, cool.
Yeah. All right. How's everybody else? Any other questions? Let me say something right now. All right. This is going to be angry Jeff for a second. Some people are using various methods to get answers to homework questions that aren't themselves. There's a couple people that have used photomath. If you don't know what photomath is, that's probably the best. If you look it up, find out what it is and want to start using it, you probably shouldn't, because I will know and you will not get credit for shit. All right. Everybody with me so far? There's also, there's a ton of shit. I'm not even going to talk about it. There's a ton of websites and there's a ton of stuff you can get answers from. That is completely pathetic bullshit. Do the work. Make mistakes. Ask questions, right? I'm not wanting you to be perfect with your homework. That would be a little weird. You're taking the class. How could you be perfect with the homework unless you already passed pre-calculus and you're doing it just, because you're bored? That doesn't make any sense. Is everybody with me at all? So if you got a message from me, several people did, on their homework saying, no credit, and I didn't even put any explanation. I'm like, you know why. I think I did say something like, I put message, I said, no credit. If you do this again, then you get a 0 homework grade, right? I just won't take any more homework from you because I'm not here to grade how well an app does work for you. That's not what I'm here for, right? Trust me, every method there is to get the answer to these have their own quirks, and I know them. And if you happen to get that stuff past me, you're going to die on the midterm and the final because you're not going to know how to do anything. All right, I'm sorry. So for those of you who aren't doing that, I appreciate you, right? I appreciate what you're doing, even if you don't get all the right answers. That's fantastic, right? I don't celebrate wrong answers, but I celebrate honest work. Okay, that's enough, Jeff. That's enough. Okay, so I just want you guys to know I am well aware of a lot. I'm not going to say all, because it seems like every month I learn about a new way for people to get answers. So I'm like, I don't know. There's other shit that I don't know about. But that is beyond pathetic. And if that's the way you've gotten through your math courses, oh man, you're going to not like this class. Oh man, it ain't going to work for you no more. It stops. Okay. Because unfortunately, some of my colleagues are a little clueless and they don't really care too much to look into it, but most of us do. All right, all right, that's it. So anybody have questions from homework that you yourself tried and had trouble with? Or is anyone using photomath wants to tell me they do and tell me if they don't understand something that photomath did for them? That would be awesome. Let you guys sort of like the rioters, the insurrectionists posting video of them doing it. That was awesome. Let's just see if anybody steps into that. No? Okay. No questions from homework? I don't want to scare you guys off. I don't, but I still, there you go. I'm not going to say. You can look into it. If you find out what it is, don't download it. Don't use it. It's bad.
I had a question from 3-2, I think.
All right, 3-2. And then I got a couple coming in fast and furious in the chat, but let me see. 3-2. Which one?
I'm not sure exactly which one it was, but it was like g of x minus g of a over x minus a.
Oh, yeah.
And then g of x is equal to x squared minus 2 squared, or 2x.
Sure.
I think it was something like that.
Yep.
What I did is like I did the same thing for g of a, where it equals a squared minus 2a.
Sure.
And then I tried to solve it. I was able to factor, sort of, but then I wasn't sure where to go from there.
So what should happen is the x minus a should cancel. So you should be able to factor the top to be x minus a times some other stuff.
And yeah, I got about there.
Oh, okay. And then the x minus a's cancel on the top and the bottom, and you're done.
Oh, all right. I just wasn't sure if I needed to go farther than that.
No, that's where you stop.
Thank you.
All right, so somebody else is asking about number 57 in 3-1. Let's take a look. Is this a visual one? Yes. So the question on that was, is it 1-to-1? Oh, okay. How do we determine if something's 1-to-1?
The horizontal line test?
Yeah. And this, I don't know, is that tricky? I don't think it's tricky, right? Does it pass the horizontal line test?
It should pass both, yeah.
Yeah, it does. It passes both. So there's a gimme. So that one, it is a function. There's right here, what happens is for just a millisecond, it's sitting still and then it keeps going. And we see that, I mean, if you turn this bad boy around, if you turn it around, it's like a cubic function. So this would actually be a cube root function. Like a parabola kind of falls over to become a square root function. Same thing happens with the cube root function, right? Somebody's shouting at me. Oh shit, what did I just do? No. Okay, wait a minute. All right, you guys have to help me out. I'm going to march through this. I'm going to pretend like that was the correct question. All right. Somebody's asking about chapter 2, number 68. Let's see. So that's going to be here, I think. Yes. 68. Wow. Oh, is that this one with the absolute value? Okay. We did that one, pretty much did that one together in class. So if you still have questions on it, you can ask me after class, but I'm not going to do it again. So I'm sorry, whoever's asking me that, you can ask me later if you want to. Where do we look to find any? Oh, okay. All right. This is I don't know. It's not all right. Let me try not to be, I'm feeling feisty after that whole thing. It does piss me off when people cheat because there's other people honestly doing work. And it just feels like, anyway, so I got to let that go. Please, dear God, if you have not watched this video yet, if you have not done everything that I've asked you to do, here's how to view the notes that I put on your homework. There's a little video. It's not even a minute and a half long. Just watch that sucker. Somebody was asking me how to see the notes that I put on your homework. This little video tells you exactly how to do that. Shit, somebody's asked me a question. Hold on. Okay. So let me see. Was that you that was asking me? There you go. Okay, thank you. I'm trying not to call you out accidentally. Let's see, 3-3, number 15. Let me get there, 3-3. Number 15. Where are you? There you are. Oh, this is sort of related to the g of x minus a thing, right? This little dude here. This one's neat. This is my personal favorite. Do you guys see how that's sort of related to the g of x minus g of a thing? So what is it that you have to build on this one is you have to, I know what f of x is. They tell me what f of x is. So right there, I know what that piece is. I don't know what f of x plus h is. How would I figure out what f of x plus h is? This is a little bit gross, but oh well. Here, let me put it on my other monitor so I can actually write on it. Come over here, you. Okay. So anybody want to help me out? How would I figure out f of x plus h for number 15? That's the problem you're asking me about, right? Did I get the right problem?
You would put
Yes.
x plus h in the equation.
Yeah, it's crazy, right? I mean, you would do what functions do. That's crazy. So if f of x is 2x squared minus 3x, f of anything, okay, Pen, Pen, come on, would be twice that thing squared minus 3 times that thing. And now you have to simplify that. And then you put that there. You have to distribute the negative, remember? And you put the answer you get to this there. Now, this one's a lot better. The g of x minus g of a thing over x minus a, you got to factor the top and kill the x minus a's. This is a little bit better. Here, you just got to pull, if you could pull an h out of the top, it'll cancel with the h on the bottom. And trust me, that will happen.
I wish I did that sooner. I did the whole thing and then factored out the h at the very last step.
Oh, I see. Okay. Well, that's normally what you do, actually, because a lot of stuff has to cancel that doesn't have h's in it. So then you're able to take an h out. Yeah. Let me see. Is that all right? Let me see. Yes. Okay. I think you're the one that asked that. Yes, you are. And then somebody else is telling me, okay, this is the one. Okay, now I'm up to this. So they meant 3-2, number 57. I'm wondering if anybody's going to ask me the question I need. We'll find out. 3-2, number 57. Oh, I love this. Yeah, you would, Jeff. So anytime I assign something that's after the word extension, that's kind of like saying bonus in a way. It doesn't mean you don't have to do it. I'm just saying it's going to be a little bit more challenging. So I really don't even want to say anything here, to be honest. So let me give you one example. Of course, what does an absolute value do to anything?
Make
it positive.
Makes it positive. Okay, so if I had a function like that, so its range is currently, let's say, this is -10 right here, right? You guys with me? So what would its range be?
-10 to infinity.
-10 to infinity. So what would the range? So that's f of x. What would happen if I did absolute value of f of x? What would happen?
It would be +10 to infinity.
No, definitely not. Once we do this, you pretty much know the answer, but where is this function negative? Where does it become negative? Where's the outputs, right? What is this telling me to do? Take the absolute value of the outputs. Isn't that what this says? Isn't f of x represent the outputs? F of x equals x shit, blah, blah, whatever the hell it is. Isn't this the output?
So it's
So
just
watch
dropping
this.
everything underneath the x?
Yeah, starting here to here, it would actually turn that around. It would reflect it. So whatever that is, it would become positive that. Whatever that is, it would become positive that. And then this one, same way, from here to here, it would turn it around. So now what's the lowest value that the new function has? So new function goes like this. Wow, 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 wow. It looks like the Loch Ness Monster. I like it. Wow.
So it'd be 0,
0, 2.
infinity.
Yeah, okay, okay. That's enough. That's all I'm going to say. I've said too much. I've said too much. Well, the nice thing is this one doesn't go to infinity, so it still has a little bit of something you have to think about, which is good. If they would have made this negative 15, it would have been even more interesting, but they didn't. Oh well. Well, let me see. Where did I leave off? 3, 3, number 12. Let's see if anybody asks a certain kind of question. Let's see. Not yet. Okay. Find the average rate of change. So I have a process for the average rate of change, right? Whenever the instructions talk about the average rate of change, I know they're talking about something like this. It's not even f of x. Well, how do I want to say this? So if I am given an f and I want to know on some interval a to b, what's the average rate of change? It's going to be f of b minus f of a over b minus a. That is the process, right? If I'm talking about the g function, then it's g's, okay? Okay. So number, what was it, 12? Ooh, 12 is yummy. 12 is really, oh yeah, that's always creepy when I say that. Ooh, it's yummy. All right. You desperately, desperately need to start realizing that this class is going to be neat. Some problems are brute force. Just use the process and start just brute force mathing this thing. And some problems are going to be conceptual. You got to think, you got to figure out, you got to think about things. This is a brute force problem. This is, you just do it. So looking at my average rate of change formula, what's going to be taking the place of B for number 12? What's the interval that I'm interested
It's 1
in?
plus h.
Yeah, so B is going to be 1 plus h, right? It's the upper part. And what's my A going to be?
1.
1. That's crazy because it goes from A to B, right? That's the idea of the process, right? So I want to do f of 1 plus h minus f of 1 over 1 plus h minus 1. That is just using the process. I think some of you guys, and I don't blame you for this because you haven't quite been weaned off of this thought process yet. Every problem is not a new thing, right? Sometimes I think math students are like, how do you know so much math? I don't. See, who's out there? Yes?
I'm having some tech. Oh, hold on.
That was trippy. You okay? No?
Yep.
All right. Okay. Is everybody okay with that? I mean, that's as much as I'm going to do there. I know the function is a little bit gross, but oh well. That's just some math. That's math you can sink your teeth into. Okay. Let's see, where am I at? Yes, okay. Just found it. Yes. Coronavirus update check. What's happening? Yes. Okay, good. So I'm up to date. When we get a chance, can you answer why there's a quiz and a stomach quiz? Yes, I will. I'll do it right now. I sort of was waiting for more people to get here, but I think I'm there. All right, I'm going to clear all this away. Is everybody ready? You got what you need for number 12? All right, here we go. So let's do this. I'm going to show you a quiz in another class of mine, just to show you what yours is going to look like, right? Let's see. Let me actually show you yours, and then I'll switch over because I can't really fully show you yours. All right. So here's the 176. If you go to modules, there's the tutoring module, and then the quizzes module will always be right here, right up at the top. So right now, if you click on quiz 1, you're like, ooh, let me take a look at quiz 1. Oh, it's locked. All right. So here's, all right, so let me, now I got to leave this and show you this other class so I can actually show you everything. So there is a quiz 1. This is where you go to get the quiz. This is where you're going to submit it. Trust me, if there was a better way to do it, I would be doing it that way. There is not. Okay. Uh-oh. Oh, you're okay, Alice. Don't worry. If you have a question, just chat it at me if you need to. Let me see. Let me do this so I don't lose where I am. Here we go. All right, so I'm going to show you a quiz from one of my classes last semester. So it's their quiz 7, and I gave them a little, hopefully you do good. Let me become a student real quick. Bam. What? This worked earlier. No, you asshole. All right, hold on, guys. I love it. Hold on, guys. Oh, shit. Let me go back. Go back. Okay, all right, let me pick a different quiz. All right, I see what happened. Oh, stop chatting at me. Hold on. Reset student. There we go. Do it. Oh, crap. How you guys doing? You guys all right? Anybody watch the impeachment trial? No? All right. Here we go. Quiz 8. Let's do quiz 8. All right, here we go. All right, so this is what it would look like once you click a quiz. This is not your quiz. This is from Math 160 Statistics last semester. But yours is going to work the same way. You're not going to get 80 minutes. You get an hour. So don't freak out. You're going to have your instructions will be here. When you click take the quiz, the minute you click it, stay with me now. See how your time starts running down? You with me? Everybody see that? All right. You can hide that if it's going to if you're going to be able to do nothing but look at that. Down here, the quiz will be here. This is not your quiz. This is a stats quiz. You can print it out if you want to right here. If you click right here, you will be able to download it and then you can print it out. You do not have to print out the quiz. You can just do the work on another sheet of paper. Let me see who's chatting at me. Okay. I got you. When you are done, what do you mean quiz saved? Oh, okay, sorry. Sorry, I'm yelling at this. When you are done with the quiz, all right, you guys are gonna love this. You're gonna love this. I really don't care what you type here, to be honest, but I'm gonna tell you to type the time you're done. So I would type 5:54 p.m. and then I hit submit quiz. Bam. All right. Now you haven't submitted the quiz yet, have you? You've got to go to the modules. Go to where it says submit quiz. It'll say submit quiz 1 for us, of course, right? And then you submit it just like you do with your homework. Is everybody with me? And I'm really sorry that that's how it's got to work, but that's how it's got to work. Okay, I've learned through trial and error. You only have an hour. Once you open the quiz, you'll have an hour to hit submit quiz. If you have technical difficulties and your time is over, email me the quiz and then keep trying to submit it to Canvas. So at least I have a timestamp that you're actually done. Is everybody with me? So once you hit submit on the quiz and you go to actually turn in your scanned work, I'll give you a few minutes there. But if it's like 7 hours later or even 15 minutes later, I'm going to be a little worried, right? Does that make sense to everybody? Anybody confused? The quiz is today, yes. Okay. All right, let me stop this. All right. So here's to hoping. So again, once you click start, you have an hour. You have until 4 p.m. tomorrow to turn it in. Yeah. So you can start the quiz whenever you want to. Just be sure you start it. Don't start it at 3:58 p.m. tomorrow, because then you only have 2 minutes, right? All right, maybe. If you have any technical difficulties at all, just email me. Let me know what the hell's going on, right? I understand. This is not ideal. Okay, so let's get into new stuff. Oh, some old stuff first. I think nobody's asked me this, but I'm going to pretend like you did. There are some questions in the homework related to the calculator. Oh, by the way, I'm sorry. This is kind of like stream of consciousness here, but did anybody notice the flyer I posted about calculator workshops? Holy shit. Where did I put that? Was that in the announcements? Yes. I like it. So in the announcements, at the very first announcement, calculator help sessions, there's a flyer. The link on the flyer is an actual, well, it's supposed to be an actual link. Oh, shit. Oh, well, too bad. So you just copy and paste that bad boy. During any of these times, one of those times was right before class today. But then they have another one tomorrow, another one Thursday, another one Friday. And they don't say that this is for any class. So the way they did it before was they had a general session where they just went over all the basics for any class. And then they had a breakout session with people asking specific questions about statistics, calculus, pre-calculus, whatever, right? So this is a really good workshop to go to. Very good. I think they're going to record it so I can post the recording up here for you guys too. And if not, I think I have an old recording somewhere if they don't do that. But I want you guys to feel like you should go to this. Okay. Any questions on that? All right. My God, that was a lot. What time is it? Holy shit, that took 30 minutes. All right. So, well, those questions too. That's a good point. Oh yeah, here's the thing. Let's talk a little bit about the calculator. There are some problems that talk about the window of the calculator, right? If you haven't started chapter 3 yet, you don't know what I'm talking about, but I'll show you what they're talking about. All right, so if you have your calculator, if you want to play along with me, let's do this. So if I go to y equals, I got some stuff in there already, but let's put something in there. Let's see, what about x squared minus 3,000. I like it. I love you, negative 3,000. Oh, Tony Stark, why? All right. So if you want to play along, you could put that in your calculator. There's the squared button right there, right? So if I hit graph right now, it could very well be strange. Oh yeah, it's even worse than I thought. Hold on. Of course, Jeff. I've got some statistics that I was doing. Let me turn this off. Don't worry about all this shit. Don't look behind the curtain. All right. So hit graph. All right. I actually am in a normal plot. So one of the most basic things you want to do. So whoever's playing along with me, you got the function in here. If you put a brand new function, you might want to do zoom 6. See how it says zoom standard? Zoom standard takes it to a negative 10 to 10, negative 10 to 10. Now, can anyone tell me then why I cannot see this function? Where is it?
Over 3,000.
Well, yeah, it's actually down forever, right?
Yeah.
So how am I going to be able to see this thing? What do I have to do? Currently, I can only see down to negative 10. So
You can change
obviously,
the
I
window
want,
size.
Yeah. So specifically, I want the minimum y to be negative 3,000 at least, right? So now watch. Everybody with me so far? I'm going to do this specific thing, then I'll show you something else. So if you go to window, you can specifically change the minimum Y right there. And I can make that, let's make that negative 3,050 right now, just to be a little below it. Let's just see what that does for us right there. If you're playing along with me, great. Make sure you get the negative button, not the minus button. So let's hit graph. All right, that still isn't that great, is it? Right? That looks almost linear. It's like the edge of the earth. All you flat earthers out there. No. All right. What else do you think I should do to make this a little bit better? This wants to go up, doesn't it? So I probably should be able to see. I can only see to negative 10 and 10 right now on the x-axis. What should I probably change?
The x-axis.
Yeah, the
Like what you can say.
x-min. Yeah, x-min, not x-men, sorry. So what's the square root of 3,000, Jeff? I don't know. I really don't know. Let's just make it negative 100 and 100. There you go. That's not bad. All right, I like it. And then I could even, here's the x-axis. I could even make the y max a little bit higher. Let's make it 500. Why not? And now it looks a little bit better. All right. Are you guys understanding that window is where you have direct manual control over what part of the graph? It is like a window, and you can move what you're looking at, right? Now, do some of you guys know about there's a zoom button I can use instead that does not always work well? There's actually a zoom. There's a lot of kick-ass zoom. This is one of my favorite, Zoom Box. But there's one, if you scroll down, there's one called Zoom Fit. So let's see what this thing does for Zoom Fit. I have a feeling it's going to be a fat parabola. It's going to fit the whole screen. Yeah, that's not bad. That's pretty good. Sometimes Zoom Fit sucks. But Zoom Fit sort of does automatically what we just did by hand in the window. All right, how you guys doing out there? So, and then while we're here, you can hit trace and you can move around on the function. Do you see that? Wee, look at me. And it'll tell you what the points are. Obviously, it skips because it doesn't calculate an infinite number of points. Poor little dude. You can also get a table. If you hit second graph, you get this in tabular form. Ooh. And do you notice how there's something called table set above window? So if I hit second window, I can set the starting point for the table, and I can set the step size. Has anyone ever seen this symbol right here before?
Is that supposed to be like a delta?
Yes, exactly. It sort of looks like a home plate, but it's a delta. So that means change in the table. So I can make the step size maybe 500. So if I do that, if I go back to table now, see how it steps by 500 now. So that's kind of nice. It's like a nice automatic XY table. That really comes in handy, this XY table thing. It's really awesome. Anyway, so that's enough. That's enough for now. All right. So as things are coming at us in the book, I will do this with you. Don't forget also, I've posted this now, right? Did I post this? Jeff, you're taking so long with this, dude. I know. There was so much shit I wanted to do. It's all right. Where did I put this? Didn't I put the calculator guide up here? Didn't I do that? Maybe I didn't. I thought I did. Oh, yeah, I did. Okay. I can't remember if I showed you guys this, but there's the TI calculator basics, which I think is this might be the sheet they're going to use. Here's when Jenny did her workshop back in fall 2015, but I don't know. This is not that bad. All right. This goes into the zooms and what the zooms do. You guys semi with me? So that's something she used for a workshop a while back. Anyway, that's enough. Oh, I'm tired. All right. Now, any questions on the calculator right now while we're in that mode? Okay. Let's get into this. Here's the topic for the day. The topic for the day is something that we sort of talked about a while back with that absolute value problem. It's called transformations. Let me make sure, actually, while I'm thinking about it, did I finish? I'm pretty sure we finished. Yeah, okay, we're good. Oh, that's right. All right, screw that. I do have a worksheet, but no, we have to do some new stuff. We have to keep going. I do have a worksheet. I'll figure it out some other time. It's like a worksheet for 3.1 through 3.4. Maybe, anyway, I'll figure out what to do with that. We have got to keep going. So let's do this transformation stuff. Work with me. All right, Jeff. Oh. My markers are all gone. All right. Well, this one is. So transformations of functions. Shoot. So we do know about complex numbers, but when we graph things, we are always going to assume we're graphing things over the real numbers. Thank the gods, because you don't want to be graphing over the complex numbers, trust me. So very, very infrequently would we do any graphs with complex numbers unless they were just a very simple graph about the real line and the imaginary line. So with that in mind, can you graph this real quick for me? What will the square root of x look like?
More than
What are
zero.
some points you can tell me? Sorry.
No negative number. Or
Good. I can't use any negative inputs. So the smallest number input I could use is
0.
0. And what do you get when you put a 0 in?
Anna?
What's the
0.
square root of 0? 0. What's the square root of 1?
1.
That's crazy. And what's the square root of 4?
2.
That's crazy. All right. So that's good enough for the basic idea of the square root function, right? So that's always increasing. It's just the rate of increase is slowing down. Does that make sense? Okay, I like it. It's sort of like saying the unemployment rate is increasing, but at a slower rate. And that we're kind of like, oh, please, you know, because we all hope it's going to turn instead of going, oh shit. So what happens to this? What if I do this? How would that compare to this? Well, let's see. What do I get now when I put a 1 in? I should have done this color coded. I don't even know if you guys could see. Can you see blue? Does blue show up? Let's do this. All right. Blah, 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 blah. Does that look like blue? Sort of? Okay. So what do I get now when I put a 0 in?
1.
1. And does everybody agree with me that 0 is the smallest thing I could put in? It's still square root of x, so it still has the same issues that this did. So 0 is the smallest thing, but now I get 1. What do I get when I put a 1 in?
2.
2. Okay. And what do I get when I put a 4 in?
3.
3, right? Square root of 4 is 2 plus 1 is 3. So, I mean, does this make sense what happened? What did happen? What does that do? It took this function and it did what visually?
Moved it.
Moved it up 1. That kind of makes sense. So it takes that function and it moves it up 1. Ooh. All right. So that is true. I don't care what function you have. This will move that function up by C, or if C is negative, it'll move it down. All right. That works for any function, period. Any function, period. I love it. All right. Even some things that aren't functions, but right now we'll just focus on functions. So what does this do instead? What if I have this? All right, that is different, obviously, than this. And by the way, one of my students a few semesters ago said, I want to make the square root symbol have a back wall. Because you guys know, and I know all too well, that your square roots kind of grow and it starts to contain other things. It's sort of like the blob. You ever seen the blob? It grows and it just eats other things. Your square root symbols sort of like start to grow and they eat. So if I had a back wall, that would be better. But oh well, that's right. So this is obviously different. What is the smallest number I can put in here now?
1, right?
Nope.
Or -1.
-1. Is everybody with me? Because now the smallest thing that could be on the inside is 0. And what makes the inside 0? -1. All right, so now maybe we should make a table. So if I put in -1, what am I going to get?
0.
0. What do I put in there to make there be a 1 inside? I put a 0 in there, right? So if I put a 0 in there, I get 1 square root of 1 is 1. What do I put in for x to get 4 inside?
3.
3. So when I put a 3 plus 1 is 4, square root of 4 is 2. So what did that do? Jeff, your color coding went out the frickin' window. Is my pink working? Yeah, so we'll do this in pink. So -1, 0, 0, 1, and 3, 2. So what did that do? I put a +1 here, but what did that actually end up doing visually? It took the black line and did what with it?
Moved it backwards.
Moved it back 1. And people have so much trouble with that. But the way to think about this is any number I put in here, the very first thing that's going to happen to it is I'm going to add 1 to it, which means all my inputs can be 1 smaller than they used to be. That's why it does the opposite of what it looks like it's going to do. So, of course, what would happen if that would have been -1?
Would have moved it
This
the
way.
other direction.
It would have went this way, and it would have been right there, right? Okay, maybe. And again, this doesn't have to be a square root. It could be any function at all, and they will act the exact same way. So now I don't have to do this weird shit, right? If they give me something, I could just think, all right, here's the base function. Let me move it. So let's try another one. What time we got? Okay. Somebody got this business? This is the most colors I've ever used. Oh my gosh.
You're saying that if that was the square root of x minus 1, that it would move forward 1?
Exactly.
Okay.
For the exact same reason, because I really want that understood. So if this was x minus 1, wouldn't all the x's have to be 1 bigger now? Because the first thing that happens to them is I'm taking 1 away from them. So could I put a 0 in here now, considering we're only using real numbers? No, because that would end up with the imaginary number. So the smallest thing I could put would be 1. So the whole thing starts at 1 now and has the same shape. Same shape? United States. Sorry. All right. Okay. So I'm going to erase this. We're going to use a different function. Same stuff's going to happen. This time I'm going to use a shortcut. So now let's say I start with the function absolute value of x. Why not? What does that look like? Anybody?
Like a V.
Tubular. That's right. And it makes sense it looks like a V. It's a first power. It's got to be linear, but it's a line that's not allowed to go negative. So it comes in, yay. Oh shit, yay. All right. I have no idea if I went through everything. Oh, it doesn't matter. Now, so that's the base function. So what I like to do, I should have done this. So all right, that's fine, Jeff. You'll be all right. It'll be all right, buddy. So if I give you a problem, let's see if green's working. If I give you this, shit, green. Can you guys see that? Yeah. It doesn't look green though. Oh, it's all right, Jeff. If I give you this, okay. I would give you this problem and I would say graph using transformations. So what that means is you would graph the absolute value of X. And I have what I call, why am I doing it this way? I have no idea. I have what I call anchor points. So there's an anchor point 0, 0, there's an anchor point 1, 1, there's an anchor point negative 1, 1. Those are the three main points. And then I would do this dotted because it's not the answer. Now, what is that going to do to my picture based on what we just discussed? Every point's going to move where?
To the right.
To the right too. I love it. So when it's inside with the variable, it does the opposite of what it looks like, right? And the way I like to think about it is, my poor little X dude, the first thing that happens to him is he loses 2. So I have to make all my X's 2 bigger than they used to be. So now this sucker is going to be, this is going to go 1, 2. This is going to go 1, 2. This is going to go 1, 2. And then it's got the same shape. So it's all about the shape, right? Don't worry, I'm not going to sing a song like that. No, stop. All right. It's all about the shape. That's why you have to know the shape of absolute value, parabolas, x squares, x cubes. You have to know the shape of square roots, so forth, right? If you know the shape and you know a few key points, you can graph any trend. You graph the base function and then you move it around. All right, let's try one. Let's see. What if I gave you this here, h of x, absolute value of x plus 1 minus 3. Can somebody list the transformations for me?
To the left 1 and down
Good.
3.
Left 1, down 3. Kick ass. So then to graph this, you would graph the base function, negative 1, 1, 1, right? So I got 0, 0, 1, 1, negative 1, 1. That's my base function. All right, I got to give myself some more points. Okay, hold on. My scale sucks, but that's too bad. Is that enough? Yes. Okay. So now I would take every point. You could do this. So, real quick shout out to my, be very careful. Hopefully you understand what this phrase means. Anal retentive. Do you guys know what anal retentive means? It sort of is,
Yes.
It's kind of like obsessive compulsive in a way, sort of. But if you have colored pencils and graph paper and you do these kind of problems on that, shout out to you. That's beautiful. If you don't want to and you don't need to, don't do it.
I definitely haven't already been doing that.
Oh, so if I go every point, left 1, down 3, left 1, down 3, left 1, down 3. How can I check my work? What point is this?
0, negative 2.
Yes, 0, negative 2. So how can I check my work? I pick a point that my new function goes through graphically, and then I make sure that that this does that. So when I put a 0 in, 0 plus 1 is 1, absolute value 1 is 1, minus 3 is negative 2. Yay. That kicks so much ass. You have a way to check your answer when you do it. Pretty good, right? Pretty simple. So any function that we know will work the same way. So what if I had this? All right, let's get crazy. M of X. Oh my gosh, Jeff. Whoa, dude. M of X. So what if I had this? What are the transformations?
Is it like when you like flip it across the square?
No. You're overthinking this.
1 to right. Down 3.
So I would go
To the left 1.
left 1, down. Do you guys understand? It's the same stuff, right? It's just a different function. That's my point. It's just a different function with the exact same transformations. So this function is kind of interesting. It's just a parabola, but it's got the same kind of base numbers, doesn't it? So 0 squared is 0, 1 squared and -1 squared is 1. But we know we connect these with a curve now, right? That's the difference. Those are my same 3 base points, but it's the shape. It's all about the shape. And then every point gets moved. Did I give myself anything? No, I didn't give myself anything. Good job, buddy. Every point gets moved. What do we say? Left 1, down 1, 2, 3. Left 1, down 1, 2, 3. That's a big ass move, but oh well, it doesn't matter. And then left 1, down 1, 2, 3. That's my answer. And then I can check my work the same way we did. Same point, it would still work the same way. Okay.
So
Maybe.
the square just means it's a parabola.
Yes. So the absolute value tells you the basic shape. The square tells you the basic shape, right? Right. But the fact there's a +1 with the X means back 1. There's a -3 on the outside, down 3. The function could change, but the steps could be the same, just like I showed you right now. I like it. Hey, Mikey. So what happens if I have, let's go back for a second. What happens here? This is neat. So let's kind of analyze this for a second. The smallest X I could use is still what?
0.
0. And sure enough, I get a 0 out. Now, how do I get a 1 to come out? How would I get a 1 output? What would I have to put in here?
1/2.
1/2. Interesting. Is everybody with me so far? What if I want to put a 2 out? What would I have to put in here to get a 2 out of this whole thing?
1 or 2.
A 2, right? Because then I would get a 4. Square root of 4 is 2. Is everybody with me? So what did it take if it was square root of X? What would it have taken to get those outputs? It would have taken 0 to get 0, 1 to get 1, and 4 to get 2, right? So what happened to all of my inputs? What happened to them?
Halved.
Each input got cut in half. Why does that make complete freaking sense? Where's the number that represents a transformation? It's with the X. It's with the X, which means it'll do the opposite of what it looks like. This looks like it's increasing by 1, but I know it's going to go back 1, right? This looks like it's doubling, but I know that's going to mean it's actually cutting in half. Because since the first thing I do to my inputs is double them, they can all be half as big. So visually what that's going to do, this is a very strange visually with a square root function, but oh well. Hold on, let me kind of get rid of some of this extra shit here. Okay. Ship. So what that does, here's my base function, 0, 0, 1, 1, and 4, 2 is my base function. And then if I want to graph this guy, this is kind of cool. This is really cool. Could just be me, that's all right. It smushes it, it compresses it. So now at 0, 0, 1/2, 1, and 2, 2. So it compressed it, it smushed it. All right, I don't know, you can't really see that so well, but oh well.
How would you explain it? Just be like, it compressed it, or what? Because before you
It's officially called a horizontal compression, which I just think is really stupid. That's the official name of it. I don't care as much about naming it as being able to do it, right? So obviously, now here's what's interesting. All right. The mistake people make is to not really listen to what I said. When the number is inside with the X, it does the opposite. So instead of doubling, it cut things in half, didn't it? So what would happen if I had it on the outside? So watch what you can do. When it's not in with the X, you can find the original function. So what's it going to do to all the original outputs? It's going to make them double.
It's gonna stretch it.
Sorry.
Is it gonna stretch it?
Yes, it's going to stretch it vertically in the Y direction. Everything that has been inside with the X affected the X direction. Everything that's been outside has affected the Y direction. Isn't that crazy? Is it crazy? Have you guys been following? Okay.
So what would you call it if it was the square root of half x? Because it would be not compressing,
then it
but
would
it would be
that would be a stretch. That's a stretch in the that's a horizontal stretch. This is a vertical stretch. If this was 1/2 square root of x, that would be a vertical compression. Right. But again, if you don't know what the name is, but you know how to do it, that's what's important to me. So if a therapist came over to me on the field and I was in pain and they're like, I don't know what this is called, but I can make the pain go away. I'm like, make the pain go away. I don't care if you can name the damn thing. All right. So this is going to do. And again, I really want you guys to get this. You're not going to get points unless you give me a base function. 0, 0, square root of 1 is 1, square root of 4 is 2. There's my base function without any transformations. I really did a horrible job. I'm going to let it go. Okay. I double. Twice 0 is still 0. Twice 1 is 2. Twice 2 is 4. So that is a vertical stretch. It just doubled all the outputs, right? Crazy. I'm crazy. Okay. All right, last thing for today, believe it or not. I spent a lot of time today doing other things. It's just silly, Jeff. There's still more transformations to talk about. This is a quick one. Reflections. Right. So everybody get out their journals. No, I'm joking. A reflection is, so here's one type of reflection. I really want you guys to get this. Is that in with the X or outside?
It's outside.
So it's going to affect up and down. So I can find, there's my original function, right? There's that, you can do it, Jeff, the dotted line. It's just going to make all the outputs the opposite. So if I have my original function, oh, Jeff, it's all crap anyway, Jeff, it's all right. It's just going to take 0 times -1 is still 0. -1, so it's going to be down here now. -2, so it's going to flip around. So now it's like this. No, Jeff, now you can put a solid. So a negative on the outside flips it around the x-axis. From up, it goes down. So it's still in the y direction. I really want that to make sense. So what the hell would this do? Where do I put this? Well, I could put it in the same place. What would this do? You know what I'm going to do there. People look at this sometimes and say, you can't do that. Yeah, I can. What would this do? What do I have to put in here now for this to come out? What kind of value do I put in for X?
Negative numbers.
Negative numbers. So, and again, it's inside with the X. So it actually affects the X axis. So it's going to be -1 now. So 0 is still 0. -1 takes me to 1. -4 takes me to 2. So it is a reflection across the y-axis. So when the negative is inside, it reflects it, bam. It goes in the along the x, bam. And when it's on the outside, bam. Only for square roots? No, for any function at all. And you guys already know that about parabolas. I mean, if I had a parabola and I had negative outside, you know that's a down parabola, right? You guys should probably know that. That's why it's a reflection. It reflects the normal parabola, it reflects it around. Okay. Whew. Let me think. I think that might be enough. All right. What time is it? I wanted to let you guys out a little early so you could get started on that quiz if you wanted to. I think that's about where I can stop. Let me make sure. I know we went through that a little bit quickly. We'll obviously do it again. The next section is absolute value functions. We basically just did it, to be honest, but there's a few little technical details we get into. So I'm going to go ahead and officially end class. If you want to go start on the quiz now, you can. It should be open, so you should be able to access it. If you have any issues with submitting your work, like Canvas won't take it, email it to me and then keep trying to put it into Canvas, right? Any other technical difficulties, try to get in touch with me when you can. Okay, so you have until tomorrow at 4. It's got to be turned in by tomorrow at 4. Okay.
Thanks, Professor.
Sure. Anybody? So let me know if you have questions. They survived tonight's class without anything weird, which is nice.
I have a question.
Yes.
The calculator thing, is it like a Zoom? Okay,
Say again?
perfect. Like a Zoom,
Sorry?
right? For like the sessions?
Oh, the workshop is definitely a Zoom workshop. There's a Zoom link on it. Yeah.
Okay. Okay, thank you.
And Larson, there's 9 questions on the quiz. We counted them earlier. 9 total, counting the A, B, C, D. Anybody else? Questions? If not, I'm going to head out.
Have a good night.
Good luck. You too. I'll see you guys tomorrow. We'll do it all again. My YouTube channel, there's a link to it on Canvas, but my YouTube channel, my name is Waller is Me. I'll just type it in. But if you go to Canvas, there's a link that says recorded lectures on YouTube right here. So if you click on that and click this sucker, it'll take you there. So then you can watch all the previous lectures. You're welcome. All right, guys, I'm out of here. I don't see any more questions. Hopefully you guys are actually there. Maybe you logged in and went back to bed. Okay. Bye, everybody.